I will try to be as fast as I can, because we will have the master plan and you will be able to ask the questions there. This is a follow-up presentation to what I told you about last year. It's about methods of dense DTM creation in PHOTOMOD. So I want to share with you the results that we achieved. Let's start with the terminology that was used a lot of times, and there is a lot of confusion here in many languages. From now on, I will be mostly talking about digital surface models. All the buildings, all the trees and constructions will fall under the surface. So this is an example of space image taken from GeoEye-1, a stereo pair for Novokuznetsk. Previously, when we launched an automatic processing algorithm, we used to obtain this not very nice picture. We had some hills that only resembled very feebly real houses. But there was nothing wrong about it, in a sense that I can use filtering to generate, to remove all the vegetation from DSM. This is done in a very simple way to make an orthophoto plan. But if we wanted a really good model, we had to rebuild manually these houses to make them look nice. Our aspiration, what we want to achieve, is the model that we have on the right, and do it automatically. Last time I classified techniques available. This one is a local stereo correlation method. In fact, it's not such a bad method. It's quite fast and accurate, but if we have some latent surfaces, for example, one stereo pair gives you an image of a wall, the other stereo pair doesn't, it creates distortions and the algorithm begins to malfunction. There are also global algorithms available. I think Gottfried had a picture on that. Semi-global matching is one of the most important. Graph cuts, simple tree. This is a method where you look for a minimum of some global functionality, and we're working on our own method. Last year it didn't have a name, now it has a name. We call it iterative differentiation method. It has a lot of details, but the idea is simple. If we know the surface, if we have one or two images of one surface and we build an orthophoto and my surface is correct, then I will have a very good orthophoto. Of course, there may be different brightness or other properties. So I will generate surfaces based on the fact that orthophotos from different images will match. So this is the essence of iterative deformation method. We do understand that in order for it to work smoothly, we need to have an image recognition method. This is a shadow, this is a building, this is a road, this sort of things. That makes this method work much better. This is a collation of local versus global. On the left we can see some errors. This is some kind of warehouse, I suppose. Instead of straight lines, we have some shabby pieces, and the local method works just fine. Semi-global matching is quite popular. It's catching on, and we're trying to implement it within PHOTOMOD. The whole purpose of SGM is to collect data from different stereo pairs, and it shows once again that this method is lends itself to good processing. The right side is very good, and the left side is quite rough. But once collected, all this roughness and unevenness goes away. But let's look at our method, the one that we're working on, work in progress. This is Novokuznetsk, the city of Novokuznetsk, and again you can see comparison between a poorer image and the one that looks much more decent. Tomorrow we will have a special presentation on Pleiades. We processed 3 stereos from Pleiades for Orenburg. The survey was done in such a way, the imaging was done in such a way, there was only 20-degree difference between 2 angles. The photogrammetric quality wasn't perfect, but still we can see aircraft, we can see special devices that are used by passengers to go to get into aircraft, and there are also some sports facilities nearby. It's not the best, but still we tested it for one of the Russian cities. Tomorrow there will be a more detailed presentation on that. This is a DMC aerial example with GSD of 6 centimeters. Thanks to GSM you can see tracks and sleepers on the railroad. This is a section of the block from the same DMC, automatically generated houses and surface features, no human interference, but in fact there is room for improvement, but it looks good just as this. This is a different example involving UltraCam camera. For this project we had laser dots, laser points, and we could see to what extent our surface matches laser points. But there was a problem that laser points have been pre-processed, and vegetation and trees didn't have, were not included, but our version had the trees, so we had to filter out laser points with a 2-meter difference. For the remaining points we had an RMS of 21 centimeters. Not the best result, but still quite an achievement, especially in the city park areas. And we can see some areas in shadowy areas, but we are working areas. Shadows are from buildings, that is. This is another example from UltraCam. These houses don't look nice. I just don't have oblique images, so I'm unable to colorize. I only have the nadir image. And this is where I would like to stop. And you can ask all your questions during the master class, or talk to me privately. This is another example of DSM that has been filtered later. This one is for Darhan in Mongolia, upon which some textures were pulled automatically, semi-automatically. And this This is a sequence of actions involved in 3D modeling using Pleiades images. Thank you for your attention. Thank you, Andrey. I hope I saved you about 10 minutes. Well, special thanks to you. Kudos, great, from the chairman. If you allow me, and in anticipation of the masterclass, we are going to grill you with all sorts of questions. You won't have any questions now. We will postpone them until the masterclass. So it gives me pleasure now to give the floor to Les